Welcome to question 7 of the 2013 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 7 we have the probability distribution of a discrete random variable x is given by the table below. For part A we're asked to show that the possible values of p are 2/3 or 1. So to do this question, we need to know that the sum of all of the probabilities must add up to 1. So that is that 0.2 plus 0.6p squared plus 0.1 plus 1 minus p plus 0.1 must add up to 1. So therefore we can see that we have a quadratic equation emerging with the variable p that we're going to solve for. So we would have 0.6p squared can be written as 3 over 5p squared, and then we'd have subtract p, and then for the constant terms we'll have 0.2 plus 0.1 plus 1 plus 0.1 gives plus 1.4, and that is going to equal 1. But to solve a quadratic equation we want it equal to 0, so we're going to have 3 over 5p squared minus p, and then subtracting 1 across will just give plus 2 on 5, or 0.4 is equal to 0. And then so that we're not dealing with fractions, we're going to multiply every single term and the right hand side by 5, so therefore we're going to have 3p squared minus 5p plus 2 is equal to 0. And now this could be solved using factorizing and the null factor law, or the quadratic formula. So in this video we're going to look at factorizing by inspection. So the next step is going to be to multiply the coefficient of the p squared term, which is 3, by the constant term, which is 2, and that means we're going to look for the factors of 6, which is 3 times 2, that add up to -5. So we're going to use -3 and -2, so we can turn this quadratic into 3p squared minus 3p minus 2p plus 2 is equal to 0. So we used the -3 and -2 that we identified before to split up that middle term. And now we factorize by grouping 2 and 2. So for the first two terms we can see that 3p is the highest common factor, leaving behind p subtract 1. And then for the next two terms we have -2 could be the highest common factor, leaving behind p subtract 1, and that's still going to equal 0. So the next step in this process is to factorize out the p subtract 1, which is the highest common factor, which will leave behind 3p subtract 2, and that's still going to equal 0. And now that we have a factorized form equal to 0, we can apply the null factor law that says p subtract 1 could equal 0, or that 3p subtract 2 could equal 0. So therefore p could equal 1, or p could equal 2/3, which is what we were asked to show for this question. From the examiner's report we can see that 46% of students got full marks for that question, with nearly all students making some attempt. And the examiner's report goes on to say that the question presented a range of fundamental problems for students, which involved mixed operations with fractions and decimals, factorizing and solving quadratics. For part B we have let p equal 2/3, and for part 1 of B we're asked to calculate the expected value of x. So firstly, if we know p equals 2/3, we can now work out this probability as a number and this probability as a number. So the probability of when x is equal to 1 is simply equal to 0.6, which is 3 over 5 times p squared, but p is now 2/3 squared. So this is going to equal 3 over 5 times, and 2/3 squared is 4 over 9, and that is going to simplify to 4 over 15. We can also work out the probability when x is equal to 3, and that's simply 1 minus the p-value of 2/3, which is equal to 1/3. So this value here is 4 over 15 for future calculations, and this is 1/3 for our future calculations. So the expected value of x, we know that that can be calculated by taking the sum of x times the probability associated with x. So therefore the expected value of x for this question is going to equal 0 times 0.2 plus 1 times 4 on 15 plus 2 times 0.1 plus 3 times 1/3 plus 4 times 0.1. So therefore, the expected value of x is going to equal, and 0 times 0.2 just leaves 0, and then we have 4 over 15 plus, and then we have 0.2 for our next term, plus 3 times 1/3 is simply 1, plus 4 times 0.1 is 0.4. So therefore, our expected value of x is going to equal 4 over 15 plus 1.6. And now to evaluate that, we're going to get a common denominator. So we're going to use the 15. So we're going to have 4 over 15 plus, and 1.6 as a fraction over 15 is the same as 15 over 15 will give the 1. And then the 0.6 is the same as 9 over 15. So that'll give 4 over 15 plus 24 over 15 equals 28 over 15 as the correct answer for this question. From the examiner's report, we can see that 29% of students got this question fully correct, and that many students had difficulty adding decimals and fractions to give an answer. For part 2 of part B, we're asked to find the probability that x is greater than or equal to the expected value of x, which is equivalent to finding the probability that x is greater than or equal to the value we just found to be 28 on 15. So this is equivalent to the probability that x is greater than or equal to, and 28 on 15 is a little bit less than 2, so we round up. So we have the probability that x is greater than or equal to 2, which is equal to 0.1 plus 1 subtract p, but we found before that that value is 1/3. So we have 0.1 plus 1/3 plus 0.1 again. And this is going to equal, 0.1 is the same as 3 over 30, if we get a common denominator at this stage, plus 1/3, which is 10 over 30, plus 0.1, which is another 3 out of 30. So all up we get 16 out of 30, which is the same as 8 over 15. So that is the answer to this question. From the examiner's report, we can see that 32% of students got the mark for that question, with many students giving 0.5 as the answer, confusing the probability that x is greater than the mean with the probability x is greater than the median. Students probably also had difficulty working with the fractions and decimals involved in this question.